Well, howdy ho, good neighbor. What we're going to take a look at today is preferred measures of centers and spread. So, what we'll take a look at first is measures of central tendency. The two measures of center that are the main focus really are mean and the median. Uh, the mean and the median will be approximately equal for symmetric sets of data, usually within 5% of each other. Without extreme values, outliers as they call them, uh, to one side or the other. So, to kind of give you a brief example, if there was a business and most of the employees made between 20,000 and 40,000, and then you had your business manager make 120,000, the mean is going to be a little bit skewed. You'd want to use the median to represent the salaries of the employees. The median is resistant to the extreme values, just like I just said. The mean is pulled towards them. Thus, for sets of data with extreme values, the median is more representative of the center and is the preferred measure. So keep in mind that when we do not have a symmetric set of data, say we have a really extreme outlier, the mean is really influenced by that outlier. If we were to take a histogram or create a histogram using a set of data that had an extreme high outlier, you could see the shape of the histogram being skewed to the right. And vice versa. If you take a set of data with a extremely low outlier and we created a histogram using that set of data, you'll see that the shape of the histogram would be skewed left. The mean is going to be pulled toward the outlier regardless, in a non-symmetric set of data. Here are some rules that I kind of wrote down on the keynote. When the mean is greater than the median, usually that means that the distribution is skewed right by an extreme value that is greater than the mean. Same goes for when the mean is less than the median. The distribution is going to be skewed left because of that extreme low outlier. The extreme values, this is important to note. The extreme values could be removed from the data for separate study, and a new, more accurate mean can be calculated. I like to do this after I give a weekly test to see or show the kids how much that outlier affects our average. So standard deviation, I know it's been on the screen for a while. If the distribution is normal or symmetric, this is a classic measure of variation. It's interpreted with the respect to the mean. And usually if 95% of the data fall between the mean plus or minus 2 standard deviations, it kind of indicates that symmetric bell shape of our histogram. Interquartile range. We kind of already talked about finding the interquartile range in a previous video. We need the first and third quartiles, Q1 and Q3. The middle 50% of the data falls between the interquartile range. this is more accurate to use to kind of define the spread of the data when we have extreme outliers. So it's more associated with the median. That's kind of obvious since the Q1 and Q3 are both medians of the lower and upper half of our actual true median. Just kind of a side note here, the standard deviation is associated with the mean, just kind of recapping, and is an accurate measure of spread for symmetric bell-shaped distributions. The interquartile range is generally associated with the median, which is what I just hit, and is an accurate measure of spread for non-symmetric distributions. And you can clearly see which one you really want to use if you create a histogram. You'll see that skew shape in our histogram if there are extreme lower or upper extremes outliers. So keep that in mind. In a second, we'll look at a histogram, and without even knowing those the mean or median or anything like that, just by looking at the graph, the histogram, you'll be able to tell which is going to be the preferred measure. Symmetry. Recall that a set of data is skewed left if the mean is less than the median, and is skewed right if the mean is greater than the median. A set of data is symmetric, bell-shaped, if the mean is approximately equal to the median. We already talked about that, usually within 5%. The empirical rule is met, and the interquartile range is approximately equal to 1.33 standard deviations. This is kind of just a summary of what we just talked about. So, what if what if we were given a histogram and we were asked which measure of center or spread, which measure would we prefer to represent the data? Now, you're not given the mean or the median, but kind of look at the shape of the histogram. If you notice to the right, we have an extreme upper outlier and upper extreme. The histogram is not symmetric. It's not bell-shaped. Okay, there is an outlier to the right of the range of the data. So we would say that this histogram is being skewed to which direction? That's the question you kind of have to ask yourself. It is skewed right. Okay. The mean is going to be greater than the median. So with that being said, we would probably want to use the median and the interquartile range to represent our data. So folks, if you get stuck again, like I said before, pause, rewind, go back, double check if anything you missed. Until next time, we'll see you later.